Hi guys, my name is Raviteja. I am studying BTech final year in Acharya Nagaraj University. I do 1 month internship in Amatech Solutions in domain of embedded systems. So in this internship, I learned introduction to embedded systems, C program basics to interface LED. LED means light emitting diode, digital keypad, buzzer, and CLCD with PIC 16F877A using MPLA, MPLab, and simulator using Pixums Lab, embedded C program for micro oven. So basically, embedded system is a microprocessor or microcontroller based system of hardware and software designed to perform a specific function within a large mechanical or electrical systems. So it means that, for example, for if we take a washing machine, in that there is a automatical controlling system like how much time it to take for a load, and how much time it wash, and how much time it rinse, and how much time it rotates. It is all are programmable. So basically an embedded system means, so to control a hardware we have to provide a certain instruction set in a form of programming in order to control the entire machine. So it is a combination of software and hardware. This is called embedded systems. Maximum we see embedded systems in micro ovens, ATMs, mobile phones, and digital cameras. So types of embedded systems: real-time embedded systems, standalone embedded systems, network embedded systems, mobile embedded systems. So embedded system components are, for example, the main component in an embedded system is CPU, and there is a software for that, there is a memory for that, and in that we have to convert digital to D comma A conversion means that uh, we convert digital to analog and analog to digital, and there are actuators and aux system power controlling, and say there are some diagnostic ports, user interface, again A&D conversions. There is a sensor means, for example, if we take a sensor, there are two types of sensor. There is a digital sensor and analog sensor. Analog sensor means we can able to read the entire process of that particular what we sense. For example, if we take a smoke, so in analog sensor we can measure the components of the content of smoke. For example, if we take a digital sensor, so the digital sensor says that whether it is a smoke or not, that's it. So the digital forms either in a form of yes or no, whereas in analog sensors we have to read the particular data. uh, that's it. And electromechanical backup and safety, external environment, these are the components of embedded systems. So the main component of an embedded system is CPU, so it is a key component, and remaining all are, the memory is also important, software is also important. So CPU means central processing unit. So CPU is the heart of the embedded system, it control entire the embedded systems. So in this internship we used two lab in order to develop that project: MPLab IDE. MPLab IDE is a appropriate freeware integrated development environment for the development of embedded applications on PIC and DS-PIC microcontrollers, and is developed by Microchip Technology. MPLab X is the latest edition of MPLab and is developed on the NetBeans platform. So another software is Pixums Lab. Pixums Lab Simulator is a real-time emulator of development boards with integrated MPLab debugger. Pixum Lab supports some Pixums microcontrollers and some SimWar microcontrollers. Pixum Lab have integration with MPLabX Arduino IDE for programming the boards of microcontrollers. So basically, an IDE means that, so there is an ability to create program set of instructions, and we have the software, right? So in order to dump the entire software into a particular board or particular embedded system, we need some IDEs. Whereas simulator means we didn't have always that uh, physical components. In order to get the outputs, we use simulators. So this is how the interface of MPLAB. So here we have that PiximLab PiximLab simulator, and here MPLAB. So in MPLAB we code what we required. For example, uh, I said I set a particular instruction like switch off automatically after 10 minutes. So in order to set that instruction, I have to give the particular requirement set of instruction in MPLAB, whereas the Pixim PiximLab gives the output. So in order to simulate the output of a output of the code, we use PiximLab. So now we take microwave oven simulator. So in that there are 5 components. First one is power on. So on turning on the micro oven on, the oven display needs to display the power on message. For example, if we take a washing machine or whatever it may be, whatever the embedded system, for example, if we switch on a particular device, so we have to know whether it is an on or not. For example, if I take my laptop, if at all I want to switch on my laptop, I need to press the power button, and in order to know whether it is on or not, so they need a display, right? So for the display, we give the some particular instruction. When we power on, display some message that power on message. And coming to the micro oven, there are some modes. So micro mode, grill mode, convection mode, start. So for every embedded system, we have some particular requirements, right? For example, uh, to understand betterly, for example, take washing machine. There are some particular uh, situations like quick wash. So in quick wash, we wash the entire our clothes in 10 minutes, whereas complete wash it take the 40 to 50 minutes to do a normal wash. So though similarly, there are some cooking modes: micro mode, grill mode, and convection mode, and start. So set time and temperature. The oven needs to facilitate the user to input required cooking time or temperature. So for example, there are some food items, right? So in order to eat some food items, so there are for every food items there are particular temperatures. So for example, if we take rice, so in order to boil, we didn't use rice, we didn't cook rice in microwave, right? So for example, if we take an egg puff or curry puff, in order to heat that, we have to set the time and temperature. So in this particular time, so please heat the food for this particular temperature. So that is what set time and temperature. Issue warning. So the oven need to warn the user in case of invalid time or temperature input when the door is opening during the cooking time. So so the oven needs to warn the user in case, for example, some of the user give invalid time, like 5 or 6 hours, or invalid temperature like 500 degrees Celsius. So in order to give the warning, so we use this issue warning code. So finally, and the oven needs to display cooking uptime, message on completion of cooking time. So my friend Karthik will continue this. Hello everyone, my name is Karthik, and I am from Acharya Nagarjuna University pursuing my BTech final year. I will continue this presentation. So now functional requirements. So one, power on the microwave oven, the CLC display the power on message, which is followed by the display of 4 different cooking models. So whenever we on the power, it is the power on message. After that, so it will display the 4 cooking methods, which already explained in the previous slide. So there are 4 cooking methods: micro, grill, convection, and start. So after that, one pressing key in the matrix keypad, micro mode is selected. So now I select the micro mode and the CLCD displays the power, so how much requires that micro mode. So CLCD prompt the user to enter the time and temperature. So star button clears the time, minutes or seconds, whereas as button confirms the time and start of cooking. Functional requirements again, time start, fan starts, key for matrix keypad add 30 seconds to the cooking time, key 5 pause the cooking, and key 4 also resume the cooking, key 5 ends the cooking. So here we use the simulator, right? So that's why we use the denote key 4, key 5, key 4 and key 5. And in order to in real world we just display the button name as cooking mode, or whether the key for is, whether the particular key is resume or pause, whatever it may be. So in order to simulate we just use a key 4, key 5, that's it. On pressing key 2 in the matrix keypad, grill mode is selected. CLCD prompts the user to cooking time. Again star confirms the button start cooking, and as confirms the time and start cooking. So the convection mode, on pressing key 3 in the matrix keypad, the convection mode is selected. Again CLCD prompt the user to enter the cooking temperature. So again the same process which already done in the previous step, but oven starts preheating with the given temperature for 3 minutes. So the convection mode set to be preheating for 3 minutes for a given temperature. So now the on pressing key 4 the matrix mode, on matrix keypad start mode is selected. Cooking time is set to 30 seconds and cooking starts automatically, start mode display. So here interfacing, so in the interface of that particular embedded system which we developed for micro oven, so there are PIC1 6F877A operating frequency of DC 20 MHz. So 5 input and output ports and 15 interrupts and 3 timers. Flash memory is 8 KB, data memory is 368 bytes. So these are the requirements to develop a micro oven. So CLCD 8-bit and 4-bit mode. CLCD, which stands for chapter liquid crystal display, it is basically it is a display. So it has two types of displays, 16:2 and 16:4. In our project we used 16:4 displays. It has total 16 interfacing lines, D0 to D7 are data lines. It has built-in controller. It has its own ROM and own RAM. That controller can execute the instruction and data. RS line, register selector line, RS value 1, RS value 0 for instruction and RS value 1 for data. So data processing by two methods, CLCD 8-bit and 4-bit mode. Data processing by two methods, delay method and polling method. Polling method means we want to observe a pin, in our case D7 pin. In polling method we want to continuously monitor D7. In data lines we are provided data as read or write read or write mode. So 1 is for read and 0 is for write. We have to set that particular read and write instruction in our programming. So but RW pin is completely grounded, which means only write on data. In CLED, D0 to D7 are connected to ports D, and RS and enable pin are connected to port E. 8-bit mode is D0 to D7, 4-bit mode is D4 to D7. So this is the CLCD pins. So first is VSS and VCC plus 5 volts, VE contrast control, R7 register value, RW read or write pin. So 1 is for read and 0 is for write, or completely grounded for write. Enable pin. So from D0 to D7 these 8 are data pins. So there is an LED, LED plus and LED minus. So 5 volts and ground. And tactical key, a tactical switch allows electricity to flow in an electric circuit by manually pressing the operation section. This switch is used to supply the input signal to actuate a device or equipment. It is designed with a small footprint suited for mounting onto the surface of printed circuits boards, which means PCBs. So made to connect electronic components to form electronic circuits. The switch activates when pressed and turns off when released. This action is called momentary action and can only perform at low voltage and low current. There are many different types of tactical switch and also known as tactical push switch or tact switch, used in variety of application including household appliances, offices and commercial equipments. So this is the structure of tactical switch. So this is the bouncing apart. So basically it is runs in low voltage modes and low current modes. So it is even work with the low current and low voltage. So this is the tactical switch in matrix keypad. So there are some 12 switches in matrix keypad. So in order to press a particular switch, there will pass a particular instruction. For example, if we press key 3, there are some instruction uh, that to switch the mode to convection mode, or plus 3 for uh, matrix mode, whatever it may be. So this is the physical form of this is the basic structure of tactical switch in matrix keypad. So timers, there are three type of timers in PSC Genius board: timer 0, timer 1 and timer 2. The timer can work as timer and controller, like for counting internal pulse and external pulses. Timer 0 is a 8-bit timer, like it will count from 0 to FF over to FF, then generate an interrupt. There are various registers associated with timer O, like TMRO, clocks or select bit. There are 15 interrupt sources in case of this microcontroller. Timer 0 has a bit GIE. If we set this bit, it will enable all the interrupts. GIE bit is common for all the functions, whether main.c or timer.c. So interrupts. An interrupt is occur when the timer 2 register overflows. So basically an interrupt is, for example, if you do a work, for example, there is a class. So one person is suddenly coming to the class. So the people who are in the class suddenly shift their all interest to that particular person. That is what called, whereas it comes into the microcontroller. For example, there is an instruction enters into the middle of the programming or middle of the function. So the interrupt will execute first, and then the program will continues. So this is what interrupt means. So there is a buzzer is connected to pin 1 of port C, and fan is connected to pin 2 of port C. Fan is for cool embedded system. So that's it. This is the micro oven project for embedded system internship. Thank you.